Hi everybody, my name is Ben, and welcome to our Introduction into 3D Printing at the Lebanon Public Library. Today we're going to go over what is 3D printing, how 3D printing is being used in the real world, as well as jumping into TinkerCAD and modeling our first object today. So let's jump into it. So what is 3D printing? 3D printing, if we had to give it a definition, is the creation of a three-dimensional object using computer-guided assistance, otherwise known as CAD. Think of this as a hot glue gun. Basically what ends up happening is we lay down one single strand of filament, or our creation material, and it builds upon itself from the bottom layer to the top. Singular layers over time will accumulate and therefore make our three-dimensional object. This is important because it's an emergent technology becoming more available to consumers, and it's something that you get to use here at the library. So why is this actually important? One reason the library has a 3D printer is it allows you to explore emerging technologies. 3D printers are really expensive, and they can range anywhere from a couple $100 all the way up to tens of thousands of dollars. We're hoping you'll feel more inspired one day to follow a career in something like 3D modeling, product design, or whatever job that may be in your future. 3D printing is cool because it allows you to turn your ideas into something real. Most ideas start with a problem, but they don't always have to be big problems. Sometimes it's something as easy as just making our lives a bit easier. 3D printing is also very cost efficient. The printer here costs around 10 cents per gram to operate. This means that you can make some really cool things for a fraction of the price of buying it at a store or online. 3D prints are made in something called CAD. This is short for computer-aided design. More simply put, when we make something into an object, we put it into a computer program that allows us to edit and make changes. This is what makes 3D printing so powerful, because we're able to fix mistakes we make by pushing buttons on a computer. Take a moment and think, what are some of the things that 3D printing is being used for? Take 5 seconds. What do you think it's being used for? Well, let's see if it's any of those. 3D printing has a lot of real cool uses in the real world. One of the reasons it's so important is because it has a number of uses, from creating toys, to helping dogs that lost their legs walk again, and even designing and printing 3D printed homes. One of the more pressing industries using 3D printing and modeling is in the use of the medical field. Using the ability to either scan in, or even make edits in CAD, designers are able to create everything from artificial limbs, to resin-based teeth, to helping introduce animals back into the wild that may have been injured. Another way 3D printing is being used is in the field of education, by showing and creating low-cost, durable, and strong models to demonstrate educational concepts. Let's look at the Gaboo Viper here, a skeleton structure that's safe and allows students and scientists to get their hands on a skeletal structure. I mean, who wants to hold a real snake's head? Language. Whether you're learning how to spell or learning a new language, did you know it's possible to 3D print things such as letters? Later in this video, I'll show you how to put your name on either a keychain or a bookmark of your choice. The solar system. Sometimes it's hard to tell how big things really are. 3D printing is used to show something called scale, or how small something is next to something big. Does anybody want to guess which planet we are on the screen? We're actually the third one to the left, so I hope this shows you just how easy it is to not understand how big something really can be. We can also do things like modeling, such as fractions, or dissecting a frog that snaps together. So this is what most of you are probably going to be using it for entertainment, for fun. This is actually one of the #1 things that our Dremel and Ultimaker 3D printers are used for. Any Harry Potter fans out there? The top left image is actually a book nook of Diagon Alley. It went through something called post-processing, or dressing up. This includes things such as painting, adding lights, but you can see how cool something can be once you dress it up and you take the time to put the effort into it. Did you know some people use 3D printers to make custom video games? The image on the right actually shows a case that was 3D printed and a Raspberry Pi that was added to it with a program that allowed them to play video games on it. Has anybody here ever lost a board game piece? I have to admit, I have. Did you know that one of the #1 things that we make on the 3D printer are things such as Dungeons & Dragons miniatures, pieces to board games, or even things such as full chess sets? It can also be used in the music industry too. This is a full working electric guitar made of a 3D printed body. Has anybody ever played Zelda games? The ocarina is a handheld flute iconic to the game. One of the coolest parts about it is that's something you can 3D print here at the library. Out of all of the uses we've talked about so far, engineering is actually the most traditional use of 3D printing. We want to make our lives easier, and that's the main goal of engineering. It's a way that we can design things and understand things to either save space, time, or energy. Take for example the top left, that's a Subaru Boxer engine, and this is a working model that can be used by students, mechanics, and it beats pulling out something as heavy as an engine out of a car to actually understand how it works. Or maybe it's something like drilling a hole in drywall. This little contraption allows you to catch all of the dust that comes out of a drill bit. Any cooks out there? Did you know you can make a folding basket that fits right next to your cutting boards? Or maybe it's something like a robotic arm, or this rotary engine out of a Mazda. Or maybe it's something as fun as a coin sorter where you can put your coins in, 3D print it, and you can turn it around and it will sort your coins one by one. It's all about making our lives easier. Architecture. From bird feeders to famous buildings, another popular way 3D printing is being used is to recreate buildings on a smaller scale. Take for example here, the Eiffel Tower. So we can either build things from scratch, or we can also make historical buildings as well. Do you remember when I said 3D printing takes a long time? Well, take a guess. The castle on the top left. How long do you think it took to build? An hour? A day? A year? What do you think? The correct answer is around 48 hours, or 2 days. So I mentioned this earlier, but did you know they can also 3D print homes? Instead of using plastic, like we do, they're actually using concrete here in a really big 3D printer. Another industry that's using it is product design. So this can range from things such as fashion, automobiles, or even the baking industry. Let's look at some of these images here. Did you know in the Shelby GT500, the front ends of those Mustangs were actually 3D printed? Traditionally, they used something such as clay to model it, and they would go and take it to an injection mold where they would go and repeat this long, arduous process. But with the ability to actually 3D print something, if there's something that they didn't like, they could simply open up their 3D model, make a change, and put it back in again. Or how about actually instead of 3D printing an entire home, you 3D print it in addition to your home, kind of like the one on the bottom left. Seems a lot more manageable, huh? Or did you know they can 3D print things such as cakes? Now, a human could probably make that cake, but could that human, perhaps make, I don't know, 100 of those in a row, exactly the same each time? Product design's a good way to prototype as well. It's a way to see if something works without having to do everything by hand. It might sound counterintuitive, but the other field that's using it is technology. Did you know that it's actually possible to use a lot of different photos, run them through the computer, and actually turn them into a three-dimensional object? We call this photogrammetry. What actually happens is we take around 100 photos from every side, the top, the bottom, the left, the right, and the computer's actually smart enough to scan this into one singular three-dimensional object. There's also photogrammetry apps that are available to download on your phone. My favorite's actually called Polycam, and you can get around 10 free scans before you have to purchase it. Another way that we actually use them is we can turn something called SVG files, or scalable vector graphics. This is the same type of technology that's being used in things like vinyl cutting and making bumper stickers. We can actually have those printed, and it'll be a two-dimensional look. Take a look at this over here on the right. That's a German Shepherd with the SVG file, the outline, and we can actually 3D print that. They make really cool silhouettes as well to hang up on the wall. From fashion to cosplay, biomedical engineering, 3D printed homes on Mars, recycling old plastics into new filaments, and eventually there will be a day that you can just press a single button and a replicator will create the object in your own home. So we've learned a little bit about how it's being used, but let's actually talk how this works and the specifics of how it works. The printer, as I mentioned before, is basically it's a hot glue gun that's guided by a computer. You may have seen things such as 3D printed pens, and those things are basically work the same way, but what's happening is we're actually using an XYZ axis to control where and when we put down our filament. When I say filament, this is the stuff that looks like weed whacker line. It's on the right hand side, and you can see our color choice is actually determined by which filament color we put in. Here at the library we have a single extruder, which means that you pick one color, and then if you wanted multiple colors, you would have to do this in something called post-processing, such as painting. It's made from a combination of a substance known as PLA, which is polylactic acid. It's corn-based, and it's biodegradable, and it's food safe. It's non-toxic, but I would not recommend actually eating it. Your prints all come from a reel, and the plastic is melted down to a tiny point of filament about the same size as the tip of your sharpened pencil. It goes up this tube and it eventually comes down into something called a print head. And the print head is actually what gets super hot, and it eventually comes out of something called the nozzle. If you look at this little piece right here, that nozzle, that little hole in there is actually 0.4 millimeters inside of that. And so that's very, very, very small that it comes out of, but it allows it to be very precise. After it comes outside of the nozzle, it actually goes into something called the build plate. And the build plate is actually either made of composite material, or in our case here at the Lebanon Public Library, glass. And it acts as a transitionary layer, which allows the filament to cool, but the build plate is actually heated, so it allows it to not warp when it comes down. While it's on the print head, it actually follows something called the XYZ axis to make a three-dimensional object. Think of this kind of like north, south, east, west. That's X and Y, but we also have something called Z, which is up and down. And the best thing about this is that we don't have to do a lot of it at all. We just put it into the computer and tell the computer to do the hard work for us. We're about to jump into our first part of the process, so let's look at the process from the beginning to the end. So, what we need to do is we need to model something first. It needs to be done in something called CAD, and that's Computer Aided Design. Soon we're going to enter TinkerCAD, and I'll show you how to either make a keychain or a bookmark with whatever you want printed on it. After we have that, we have to export it and we have to put it into a language that the 3D printer can actually understand. And this is called a slicer. And essentially the slicer acts as a piece of software that goes between your model and the actual communication of the 3D printer. Once an object has been sliced, it's able to be 3D printed, and it takes a different amount of time depending on the model, but most models, the size of your fist, take anywhere from 6 to 10 hours to print. Alright, so I am on TinkerCAD.com, and the cool thing about TinkerCAD.com is it is a free resource that you can use to really get your hands dirty on one of the most basic and easy to use entry-level CAD softwares. So if you don't have an account, I would begin by pressing signing up and verifying your email so that you can get in. I already have one, so I'm going to press login, and it's my personal account. I'm going to use my email to log in. And one of the nice things about TinkerCAD is you don't have to have a very powerful computer because all of the processes are done off-site on a cloud server. So if you do any work on this, you don't have to worry about bringing your computer in. All you have to do is log into either your TinkerCAD account at the library, or otherwise what you can do is you can save it to a USB drive and bring your design into the library. But let's begin. On the left, I'm going to press Designs. You may already be on Designs. On the right hand side, it's going to say New. I'm going to press this, and I want a new 3D design, the top option. Good deal. Alrighty, so this right here is what it looks like when you first enter a TinkerCAD design. This is a blank slate, a clean canvas. And the very first thing that we need to do is, you see where it says Glorious Go-Go Touring? That's not the name of my bookmark, so I'm just going to rename it Bookmark. And press Enter. And we're going to do both a bookmark and a keychain. They're both very similar, and they use very similar objects. If you want to move around, you hold down your right mouse button, and that allows you to do something called painting, where you can look around at different angles. Alternatively, in the top left-hand corner, there is a cube, and this cube, if you left-click it, will allow you to go to different options within it. So if you're not quite sure where you're at, you can use this cube to help orient yourself. The first thing we're going to do is we're going to go over here to the right hand side, and we're going to left click, drag, and hold a box onto our work plane. A work plane is very similar to a build plate in 3D printing, but a work plane is the very bottom layer, and it's important because we need to make sure that we're actually on that layer. Alright, if you use your middle mouse button, you can actually zoom in. And here there's 5 different white dots, and these dots represent the cube that we've pulled into it. So if I left click here, it'll allow us to either change it by typing, so 10, or we can actually drag it back out to what we want. This 5th one that's at the top here determines our height. So as we left click and hold, we can move our height. Let's go ahead and make ourselves a bookmark. So I'm going to go ahead, and we need a pretty thin one, so I'm going to go ahead and guess and say 3 millimeter. In terms of our length here, I'm just going to guess and say maybe 75. And one way you can tell, because 3D printing, if you haven't noticed, uses millimeters. But if you're unsure, you can actually go to your settings and change your millimeters to inches. And that will tell you roughly how many inches it is, so around 3 inches. But I'm going to change mine back to millimeters because it's a lot easier to do precise movements of millimeters, and most of 3D printing uses millimeters. Alrighty, so this right here is our basic little shape that we're going to use from it. It looks pretty good. Alright, on the right hand side there's a button that says text. If you left click and hold and drag this in, we can actually change this. So since my name isn't text, I'm going to change it to my name, Ben. And you see that's really big here. So our dimensions here of our bookmark are 75 by 20 by 3. Let's see what we have here. We have 51 by 20 by 10. So I'm going to go ahead and drag this down first. I'm going to do 5. So we'll do 2 millimeters higher. I'm going to left click here. I'm just going to round this up. And I'm going to say, actually, let's go 60. That's a good size. What was our height? 20. So this right here is right on the edge. That's a little bit over. Let's just say we want to do 15. There we go. So if I drag this on here, we could line it up. Good deal. Alrighty, so there's one last thing I want to do to show you guys how to get it perfectly even. If you hold down the left mouse button, you can make a box, and what this does is this is a selection tool. At the top right, there's a button that says align. If you want to go ahead and press that for me. And what we're going to do is we're going to align this object perfectly center. So if you press the center button here, and the center button here, this will put our text perfectly center on our bookmark. If I want to group this and make it one object, for example, if I try to move it now, it doesn't stay together. But if I want to make it one object, I can highlight everything, come up here at the top, and press group. This right here is actually called a raised face on this, and the reason you can tell is because it's raised above on the bookmark. Now, let's say that we wanted one that wasn't raised. Let's say that we wanted our name engraved inside of it. So what I'm going to do is I'm going to make a copy of this by coming up to the top after I've selected it. There's a button up here that says copy, and the button next to it, as you can guess, is paste. And what that does is that actually makes a copy of your bookmark. This is good if you ever want to, if you're not sure if you want to make a change or not, and you want to go through the whole process of undoing things, you can often make a copy of something first and then practice on it to kind of see if you want to go back or forth. So what I'm going to do with this one here is I'm going to press a button that says ungroup. So just like how we grouped it into one before, I'm going to ungroup it. I'm going to left click on the text, and there's a button that says whole here. So I'm going to press whole, and I'm actually going to raise this just a tiny bit. There we go. I'm going to left click and hold to highlight, and I'm going to press this button that says group again. And what you'll see is when these two are next to each other here, this one is now engraved and this one here is raised. Okay, so making the keychain is very similar to making the bookmark. So you're going to do the same step that you did to make the bookmark. I'm going to begin by left clicking and getting rid of this bottom one. So I'm going to left click and press delete on my keyboard. And what I'm going to do is on the right hand side, if you scroll down, there's one that says tube. I'm going to go ahead and I'm going to drag tube onto the build plate here. And what you can see is if you zoom in here, this is a lot taller than this. So what I'm going to do is I'm going to grab the height here and I'm going to drag it down until it's flush with the body. And you can tell because it starts to turn colors on that. Alternatively, we can always try to measure it out, but you can see how it's blending colors here. That's how you know that it's ready to go. So I'm going to zoom back out, and I'm going to use my left mouse button. I'm going to make a square and highlight, and I'm going to press the button that says group. And there we have it, our keychain. When you are all done and you're satisfied with your bookmark or keychain, there's two more things I need you to do. The first one is I need you to click on your object with a left click and highlight it. What this does is it will select it. And I need to make sure that your object is actually on the build plate. Sometimes we'll be building things and they'll actually be up in the air, which could cause a big problem when we go to 3D print it. So I raised this on purpose, But if you press D, the letter D on your keyboard, after you've selected an object, it will drop it down to the very bottom of the build plate. After that, if you're all ready, all you have to do is come up here to the right and press the button that says Export. And we need the file type that says STL. This is what allows us to actually communicate with the slicer, which will then send the job to the 3D printer to be made. So click STL. Next, I'm going to press this little up arrow, Show in Folder. From here, I've already plugged in my USB drive. It's here on the left says USB D drive. I'm going to go ahead and I'm going to drag this bookmark over to the D drive. And I'm going to click it, and you can see there are my bookmarks. I want to thank you for watching this guide today. On the screen you see a couple additional resources that I've included if you want to continue this journey and learn some other things. Obviously there's our 3D guides that we release from time to time, but if you're looking to create your own creations or take some of the lessons on TinkerCAD, it's a good place to start to kind of gain that three-dimensional perspectives that you need to kind of navigate the 3D printing world. Thingiverse, if you've never been there, what a wonderful site it is. It's a really good place to go to see what other people have created, and often these downloads are free and you can bring them into the library and have them 3D printed. Your library card actually comes with LinkedIn Learning, which is a self-guided course, and it's available through the Lebanon Public Library databases. It's free. All you need is your library card number, and there are lots of different classes you can take, even things outside of 3D printing. And then finally, there's always YouTube, but keep in mind, as great as it is community driven, so there may be good or bad information, but some of the best, most condensed courses I've ever taken have been through there. Thank you for watching, and I look forward to seeing you soon.